In this video, we are going to see about priority scheduling algorithm. Here we will see the priority scheduling which is of non-preemptive type. Okay. Here we are having 7 process with its priority level mentioned and its arrival time and burst time. See, in the priority, we will be having this H and L marking. The number near the H marking is the highest priority. That is here. The highest number has the highest priority and the lowest number has the lowest priority. So, among these process, the process P6 has the highest priority. Based on this algorithm, the process which has highest priority will be running first. After that, the least priority process will be running one by one. Okay. Now, we shall draw the Gantt chart. So, at 0th millisecond, see the arrival time at 0 millisecond, we are having only P1 process. So, this P1 process will be executing. It is a non-preemptive type. So, it will be executing up to 4th millisecond. Okay. After that, if you see at 4th millisecond, if you see means we are having up to P5 process because the arrival time of P5 process is 4th millisecond. So, among these 5 process, which has a highest priority. As the highest number has highest priority. Among these 5, 10 is the highest priority which belongs to process 4. So, process P4 will be executing next. After this, P4 will be executing with the burst time 5 millisecond. So, from 4 plus 5, that is 9. Okay. Then after that, if you see here means 9 millisecond. See the arrival time for the last process, that is P7 is 6th millisecond. So, by the time 9 millisecond, all the process have entered the system. So, now you need not to check whether all the process are arrived or not because we are having all the process in the system. So, while considering all the process except the completed process P1 and P4, what is the highest priority? Process P6. That is 12 is the highest priority P6. So now the process P6 will be executing. The burst time of process P6 is 4. So 9 plus 4, 13. So up to 13 millisecond process P6 will be executing. After that, the next priority is 10. That is P4 already completed its execution. Next, if you see means P7 has priority level say 9. So, P7 will be executed. The burst time is 6 millisecond. So, 13 plus 6 up to 19 millisecond P7 will be executing. Next, after P7, this P5 has next priority, that is 8. So, P5 will be executed. The burst time of P5 is 1. So, up to 20 millisecond P5 will be executed. Next, priority is 6 that belongs to P3 process. So, next P3 process will be executed with burst time 3. So, 20 plus 3, 23. Up to 23, P3 will be executed. Next level is P2 which has priority 4. So, P2 has burst time 2. So, P2 executes from 23 to 25. Likewise, all the process have completed its execution. Now, we have to calculate the completion time, turnaround time, waiting time and response time. So, completion time, if you see means for process P1, the completion time is 4th millisecond. For process P2, the time at which the process complete is 25th millisecond. For process P3, the completion time is 23rd millisecond. For process P4, the completion time is 9th millisecond. For process P5, the completion time is 20th millisecond. For process P6, the completion time is 13th millisecond. For process P7, the completion time is 19th millisecond. Next, turnaround time is computed using the formula completion time minus arrival time. If you compute like this means, we'll be having these values for turnaround time. I'm simply subtracting the completion time and arrival time for each and every process. Okay. Next, we can calculate the waiting time by using the formula. Waiting time is equal to arrival time minus turnaround time minus burst time is the waiting time. So we have to subtract this turnaround time and burst time. By subtracting, I am writing the values for all the process. Okay. Next, the response time. So for non-preemptive algorithm, the waiting time and the response time will be same. So simply write the same value for response time